Okay, so let's quickly go over the different types of blocks on the periodic table and different types of electron configurations we can write. So first we have the periodic table split into technically 4 blocks, but we're really just going to use 3 in this course. We have the S block, which holds 2 electrons each. We have the P block, which holds 6 electrons each. So we have 2, we have 6, and then the D block holds 10 electrons each. So of course our S block, we have group 1 and 2 metals, and also helium gets moved over here when we're writing our electron configurations. We have the P block. This includes some non-metals, metalloids, and then of course our D block is a lot of our transition metals, and our F block is kind of beyond our scope. I believe they hold 15 each, but not too worried about that. So of course our electron configurations, we have, like I said, different blocks. We're going to write them. Like this is the 1s block, and this would be, so if we write helium, there's 2 electrons in each when we go left to right. So we're going to say helium, and if it says to write the complete ground state electron configuration, ground state means that it's not an ion, so we're not taking or adding any electrons. So we'd have 1 because that's the energy level we're in. This is energy level because we're in the first period of the periodic table. And then the S is the sub-level we're in, which is like the block, if you want to visualize it. And then we have 2 electrons because we have 1 proton and then 2 protons, and we have a neutral atom, so we're going to have 2 electrons because we have an equal amount of protons and electrons. And so our complete electron configuration is 1s2. So if we try to do hydrogen, the ground state electron configuration, we're going to look at our periodic table, and this one's pretty simple. We have hydrogen right here, and we're in energy level 1 because we're in the first period. We are in the S because we stayed over by the metals, and we only have 1 electron because hydrogen has 1 proton. So then let's say we went to carbon, which is going to be right here. We're going to say, okay, we have 1s2 because we filled this period completely, and then we have 2s2 because we filled this guy completely, and we got to keep going. So then we have 2s2, and now we're in the second period, so we're using 2. Then we're going to skip the D block because until we get to the 4th energy level, we don't go into the D block. And so then we are going to say this is 2p because we don't have a 1p block. We only have a 2p block because there's no block right here because this helium moves over. And then we have 1 and 2 electrons. So we're going to say this is 2p2, and this makes sense because we have 2, 4, 6 electrons, and carbon has 6 protons. Okay, let's try aluminum next. Aluminum is right under boron on the periodic table. So a shorthand is we could write what we already have with carbon. We can start from carbon. Let's say we know that this is going to be filled. So we know that it's going to be 1s2, 2s2, 2p6, right? Because we already finished the second period, and now we're going to go down. And so we're in the 3rd energy level now. So we're going to say 3s. And we went to the S because we need to go to the P block. And this is the start of the P block, and that's where our element is. And so we know that we are going to have 1 electron in our P block, and so we're going to have 3p1. And then iron is, iron is 26, so it's 1, 2, 3, 4, 5, 6 over. So 1, 2, 3, 4, 5, 6 over, correct? 6 over, iron right here. Yeah, and then we are going to continue. Once we get down to these D blocks, we can kind of use our noble gas notation, which I'll teach shortly, but let's just write the full one out. So we have 1s2, 2s2, 2p6, 3s2, 3p6, because now we're going into the 4th energy level. We have 4, now we're in the 4th, so we have 4s2, And a tricky part about this D block here is that it's going to backfill. So we're going to go one less than the highest energy level we have right now. So we have a 4s as our highest energy level, but we're really going to say that this is the 3D sublevel right now. So we're going to backfill. And this is important when we get into ions, when we see that we need to remove some electrons or add electrons even. We have 3D, and we have 1, 2, 3, 4, 5, 6. So it's 3d6. Okay, now let's talk about ions. So an ion, you subtract or add electrons depending on the charge of the ion, and you reflect this with the exponent. So if I have Fe2 negative, we're going to take away we're going to add 2 electrons, and if we have an Fe2 positive, we'll take away 2 electrons, right? Because electrons carry a negative charge. So if we're taking 2 away, it's going to be a partially positive atom. So if we want to write our noble gas notation, we look at these guys, our little noble gases here, because our noble gases, remember, have our 8 electrons that they want. So the 2s2 block, for example, and the 2p6 both have 8 electrons, and that's the second energy level. So it's a shorthand way. If I said to write zirconium, which is pretty far down, it's right here on the periodic table, instead of going all the way through these 5 energy levels, we can just say, okay, well, we know that the third noble gas down, our 4th noble gas down is krypton. So this is krypton right here. So then we abbreviate our noble gas notation and say that, okay, zirconium, which is Zr, is equivalent to, we put our noble gas in brackets, so Kr, and then we're just going to finish our incomplete, our period on the period table. So we'll say this is 5s2, we have both electrons filled, and then remember we backfill, so this is going to be 4d, and we have 1, 2. So we have a 4d2. Awesome. And then just when I'm writing an iron electron configuration out, let's just copy and paste and say, or even look here and say that I want to write a Fe2 positive and I want to take 2 electrons away. I'm going to pull from the highest electron level, which is this 4 here. So I'm going to pull away because they're the farthest from the nucleus, and so they're going to be the easiest to take away, and they're going to be the ones that are removed first. So instead, we're just going to subtract these 2, take them out basically, and since we have 2, they can't, that whole energy level cancels, and we have 1s2, 2s2, 2p6, 3s2, 3p6, and 3d6. And that is, in summary, electron configurations and some abbreviated electron configurations.